Welcome everyone to our session this afternoon, which is around AWS cryptography and the services that we have, and hardware security modules and when they're used, and the choices and options you have as a customer. We're going to look at the range of AWS crypto services that we have, because there may well be a suitable service there for you when you think of hardware security modules. And then we're going to deep dive on the Cloud HSM service itself. Avni, would you like to introduce yourself?
Absolutely. I'm Avni Rambia. Hi, everyone. I'm the product manager for Cloud HSM. It is my goal that you find an alternative to Cloud HSM today. It is my single purpose for this talk. We'll go through several alternatives, Squig will, on different options for your use case. And then if you must use Cloud HSM, we'll go through a whole bunch of power user features to make your lives a little easier.
Hey. I'm Squig. I'm a principal security SA at AWS. I've been here 6.5 years. My focus these days is with our financial services customers, large and small, many of whom have very rigorous crypto requirements when they're using our platform. So, first of all, we'll look at the services that we have available for you to use and help you understand the right service for the right job. Then we're going to look at the fundamentals of the Cloud HSM service itself, and then how you can what design goals you might have and how you can start to optimize your design for cost and efficiency. And then we'll have a look at what we've recently released for the service and what will be coming up on the roadmap. It is primarily focused on the Cloud HSM service, but we're going to spend quite a bit of time talking about the other services first of all. So, AWS cryptography.
Sorry, this is a quick shout out. So we just announced root CA for Private CA. For anyone who's been using Cloud HSM because you couldn't do root CA on Private CA, you can go to this talk. It's almost right after hours, and you can see how to get rid of your HSMs.
Yep. Okay. So AWS Cryptography Services, selecting the right tool for the job that you have in hand. When our customers talk and think about crypto, there's a few common use cases. Encrypting sensitive data within applications and protecting the keys using a hardware security module. It's creating a PKI infrastructure for authentication between services that are private. So this isn't about public CAs and building TLS for webs. This is about doing internal PKIs to protect your own services. It's about the secure storage and retrieval of secrets from applications at boot time. So an application starts up, it needs a set of database credentials, for example. Or it's about having direct access to a FIPS level 3 validated hardware security module that they control themselves. When customers tell us that they need a Cloud HSM, typically what they feel is that they need more control than an AWS managed service gives them. Most of the time, customers are happy when they understand that we're using HSMs on their behalf and that we control those HSMs, and we give customers comfort back that we're doing a good job of doing so. Typically, customers don't need or deserve the full terror of running their own hardware security modules. And I've built one, so I understand how terrifying it is. So for customers, it's about this balance between control on one hand and simplicity on the other hand. And as you're probably used to with AWS, we give you a choice across that spectrum. All AWS crypto services are backed by FIPS validated hardware security modules, full stop. The difference isn't about security, it's about the control and flexibility that you have, and it's also about the costs of these things, because there are very different costs between using an AWS managed service and running your own fleet of hardware security modules. So let's move on now to talk about the different AWS cryptography services that you have available to you to meet encryption, signing, certificate management and PKI needs, and how to choose what option works best for your use case. There are 4 services in this portfolio, so all of this fits under the banner and the service of AWS cryptography. There's the AWS Key Management Service that gives you an easy way of encrypting data as it flows across different AWS services. We have the AWS Certificate Manager, Private Certificate Authority. AWS Secrets Manager, that helps you do secrets management. And then finally, the raw control of the AWS Cloud HSM service itself. So the first use case, I want to encrypt sensitive data within my AWS applications. AWS KMS is designed for this task. Virtually every AWS service, I think it's 117 services now, integrate with AWS KMS to help customers encrypt their content by simply clicking a button and selecting a key. It's absolutely awesome. Customers can use KMS to generate strong encryption keys that you can then use in your own applications. For example, to encrypt sensitive fields in a payload before you store it in a database. You can generate master keys within the KMS service. You can bring your own keys from your on-premise HSMs and upload it into the service. Or, if you have really rigorous FIPS Level 3 requirements, you can back KMS with a Cloud HSM that is fully under your control. So KMS is a key manager. You don't have access to the back-end HSMs. The service does. So on your behalf, when you're using KMS, there is a FIPS 142 Level 2 HSM fleet sitting behind that service. You get a really simple API that can generate data keys that can encrypt things and decrypt things for you. And every time any of that happens, you get a record in AWS CloudTrail. So it's a fully auditable service. As you use different AWS services, EC2, RDS, you can check a box and say, this is my master key, and KMS use that master key to protect all of the data keys that are being used to do this encryption on my behalf on the AWS services. You don't have to worry about ciphertext. These services perform the encryption in line between you and the back-end storage. So it makes it really simple for you to consume the data, but get the expectation that all of that data has been encrypted using really good crypto on your behalf by an AWS service, and your keys safely stored in a hardware security module. When you bring your own keys to AWS KMS, you take over the redundancy and durability of your keys. If KMS loses its fleet in a region, it will lose your keys. You have to go through the task of retrieving your keys from your own HSMs and importing them back into the service. Again, we're giving you balance here between it. And finally, if you really don't want your keys stored in an AWS managed HSM, you can choose to have your customer master keys stored in a Cloud HSM running on AWS that is fully under your control. It's an expensive option. You have to have those HSMs on. Again, you're taking over some of the control here for resiliency and durability, but you still get the really simple KMS API. You get all of the AWS service integration that KMS offers you. So you have all of these choices available to you. I would always say, look at native KMS first and work backwards from there and understand what one fits your individual security needs. When you want to use KMS keys within your own applications, we have the really straightforward AWS Encryption software development kit. So this makes it easy for you to take this service and all of the strong security and do really good crypto in your application. So that, for example, you have a web application, it receives personally identifiable information. You want to encrypt that information before you store it in a back-end database. This makes it really simple to do that. It supports different languages. It has a really easy data format for you to use. Again, it's open source, and at the end of the day, all of the key material has been backed by AWS KMS and a FIPS validated HSM. So it takes away, cryptography is really difficult. You know, it's one of those things as a security person, don't try and write a new crypto system, don't try and write a new identity system. This takes all of that away from you and means you can get on with the task of building really robust applications, but we're doing the hard work of the crypto on your behalf. Let's look at the next use case. So you need to create a PKI to authenticate internal servers or devices. I remember building my first PKI years ago, and it was a Windows NT server that sat in a cupboard and it came out now and again, and you used it to distribute keys. It was pretty difficult. The AWS Cryptography Team SDK has appeared here as well. Thank God I covered that properly. Amazon Certificate Manager Private CA takes the heavy lifting away from running your own PKI. When we first launched this service, it was a subordinate CA. You had to take the certificate and sign it with your own PKI. Thankfully, a few days ago, we also released the function for it to be a full root CA as well now. So you don't need to take your keys and sign them anywhere else. You can use AWS and generate your entire private CA and use this then to issue, revoke, and update certificates. It's really easy to use. Certificate rotation is one of those things that kills everyone. This can do this on your behalf. And again, take away the heavy lifting and the worry, but give you really, really strong security back with the simplicity of an AWS service. Private CA is backed by FIPS 142 level 3 validated HSMs on your behalf. So private keys are staying in a level 3 validated HSM. You get a really simple API at the front end for issuing and distributing your certificates. This is a fraction of the cost of running your own HSM fleet and then running your own CA on top of that as well, which was one of the use cases we heard about before this session. So let's look at the next use case, the need to securely store and retrieve and use secrets within applications and servers. AWS Secrets Manager is the right service for this job. So Secrets Manager was launched a few years ago now, last year, very mature service, been used by very large AWS customers around the world. That makes it really simple to put lifecycle management around secrets. Again, standard AWS API, so that when your application starts, you have an identity and access management role attached to your EC2 instance, call the Secrets Management service, retrieve your secrets, start using them. The magic is it can automatically rotate secrets for you as well. Now, secrets are only good as long as they stay secret. So good advice is to rotate your secrets very regularly, and I would ask you how often you rotate your secrets. With Secrets Manager, you could be rotating your secrets on a daily basis. So we've integrated rotation with Amazon Relational Database Service, RDS, for example. You can write your own custom rotations using AWS Lambda. So you can integrate this with anything. And what the service can do then is generate the new secret, safely rotate over, discard the old secrets. You just got on with worrying about building good applications and running it. All of the key rotation is happening on your behalf in the background. And every time all of that happens, you get all this beautiful AWS Cloud Trail information about what happened as well. So you have a full audit trail of all of that activity. There are fine-grained policies that control access to the secrets. Again, they shouldn't be split too wide. And this is backed by AWS KMS that is encrypting those secrets on your behalf. So again, the root of trust of all of this becomes a FIPS 142 level 2 validated hardware security module. It also offers pay-as-you-go pricing. You don't have to install any software. So it's very cheap to get started. It's very cheap to run in the long term as well. You can use this from on-premise, for example. It's just an AWS API, so you can start to look at how you can use this in hybrid deployments as well. Really, really simple. Now, we've got to the meat. I want to have direct access to a FIPS 142 level 3 HSM that you control. If I've managed to solve your problem before we get to this slide, congratulations, you can now leave. You don't need a Cloud HSM. But if you're still here, maybe you really do need a Cloud HSM, and I'm going to pass over to a proper cryptographer, Avni, who can talk about the service.
I work with proper cryptographers who make me look smart. Those are the cryptographers over there. Guys, can we all wave to the Encryption SDK team here? They do amazing work on your behalf. All right, so we're going to dive into the basics of Cloud HSM. We're going to look at a couple of power user tips for Cloud HSM. I have a problem. I talk very fast when I'm excited about stuff, and I love Cloud HSM. So if I'm talking too fast, please wave me down, and I promise to slow down for a while, at least. All right, so we'll cover the fundamentals of Cloud HSM. You are using an HSM in the AWS cloud because you need low latency access to a secure root of trust. And you need that root of trust to be under your control, right? What are the aspects of control? Who can administer and use the HSM, the user management? The algorithms and key lengths, right? So what kind of encryption, what kind of signing, which kinds of algorithms, AES, RSA, blockchain, what lengths of keys, 256 bits, 2K, 4K, what kinds of algorithms and what kinds of ways. These are general purpose HSMs that give you far more flexibility as compared to the fully managed AWS services that have picked the ideal algorithm and key length for your particular application. You have control over your application development. Most HSMs will give you industry standard SDKs, Java, C, OpenSSL. And then you have control over demonstrating compliance with whatever rules you have, whether they're internal regulations or external. Now, in return for that control, you inherit responsibility, right? For anyone who's had the misfortune of running a fleet of HSMs in-house, you know that high availability is difficult. You have to configure each client to talk to every HSM. You have to monitor that uptime yourself. You have to load balance yourself. When you need additional capacity, you have to provision and clone everything and configure everything yourself. The maintenance is your responsibility, right? So updating firmware, if there's a security vulnerability, patching your HSMs, changing to new versions of FIPS-approved firmware as NIST changes what algorithms they have approved and disapproved. All of that is your job. And backing up your data, because if you lose the keys that are on an HSM, the blast radius typically is business critical. You are storing your roots of trust on these things. You also have to worry about application integration and user management. So when we built Cloud HSM, our goal was to take away a lot of the undifferentiated heavy lifting without impacting the actual control that mattered. So we've automated high availability. With Cloud HSM, you've got zero config HA. Add an HSM, delete an HSM. We take care of the reconfig of every client. The load balancing is automatic. The failover is automatic. You just have to run the client. Provisioning is one click. It's either an API call or a button press on the console. The HSM comes up fully configured and ready to go, part of the cluster, equivalent to any other HSM in the cluster. We transparently handle all maintenance for you. So firmware upgrades are transparently handled. If an HSM hardware is to fail, it's transparently replaced. You will see an event in your CloudWatch logs, but other than that, your application notices nothing. And we automate backups for you. So backups are taken automatically every 24 hours. They're also taken whenever you add or you delete an HSM. And so you can be assured that the keys that are in your HSM are safe. You can also copy backups from one region to another. There is no cost for this API call. And so if you have compliance requirements or durability requirements where your keys have to be present in multiple regions, you no longer have to provision and run HSMs in every region. You can just copy the backup over wherever you need it to be.
In Avni, there was a really nice point there that you made about logging, for example. So when you call an AWS service, you get all the logs back as AWS CloudTrail logs because you're calling our APIs, and it makes it really simple to take those logs and audit them and use them in the way that you generally use CloudTrail. But when you're using the Cloud HSM, you're talking directly to the HSM. You're responsible for logging.
You are, and that's an important distinction. I'm glad you brought it up, Squig. HSMs being under your control are also your responsibility to monitor. So the client software gives you logs, the HSM gives you logs, but none of those are in CloudTrail because they're in your data plane, which is end-to-end encrypted and is invisible to AWS. So you get control over your HSMs, but you take responsibility for your logging. We can't give you those operations in CloudTrail anymore. Now, you're also responsible for user management. You cannot use IAM roles and policies for HSM access. I'll say that again. You cannot use IAM roles or policies for HSM access. This is explicitly outside the scope of AWS. So you create your cryptographic officers, you create your cryptographic users, you rotate the password. And if you lose the password, you've lost your HSM. There's nothing we can do. We can't see it. All right? So With that said, let's talk about a couple of concepts in Cloud HSM. The most basic construct in Cloud HSM is a cluster, right? A cluster is a regional construct. Every HSM that you create lives within a cluster and is grouped with other HSMs within that cluster. HSM instances are FIPS 142 level 3 hardware-based instances. They come from a third-party manufacturer. The firmware is signed by NIST, again, comes from a third-party vendor. And each HSM inside each cluster is identified by something called a masking key. The masking key makes each HSM belong to that particular cluster. It's created when you create the first HSM into a cluster that you've created from scratch. And any of the synchronization that we do of key objects between those HSMs is protected with that masking key. It's considered to be a cloning operation that's within the FIPS boundary of the HSM. Right? So you have a cluster, it's a regional construct, every HSM within it is a clone of every other HSM. And as you create and delete persistent keys, or what we call token keys, in this cluster, they're automatically synchronized between all the HSMs using the masking key that's built and is cluster unique.
And again, an important point there of control. When you bring that HSM up, you can validate that FIPS signed this. You can do these things yourself. So that attestation that this is your HSM and not someone else's, you're in control of all of those things. So you get that high level of confidence in what you're using.
Yeah, you're not trusting AWS on anything really at this point. Now, when you add or delete HSMs, the magic that makes all this work is a backup. A backup is a snapshot of your entire HSM, the certificates that demonstrate your ownership, the keys, the users, and any policies you've put in place, including quorum controls and key sharing, right? When you add an HSM to the cluster, we take a backup of an existing HSM and restore it to the new HSM. And that's how it comes up fully configured. Each of the HSMs then communicate the new IP address back to every client. The client knows there's a new HSM in a cluster. It pulls it into the load balancing group, and off you go to the races.
And the backups are stored in Amazon S3?
They are stored in S3, they're protected with KMS, but more importantly, they're protected with a key that comes from the FIPS validated manufacturer, as well as a key that comes from the AWS fleet, and it remains locked down to your credentials. So you can only restore a backup to your cluster on genuine hardware in the AWS fleet.
And the great thing is, when your backup's stored in Amazon S3, it has access to the durability that Amazon S3 provides. S3 is designed for 11 nines of durability, so it's a very safe place for your backups to give you confidence that over time, you still have a backup of this thing.
Now, you can create a cluster from scratch, or you can image one cluster from another cluster's backup. When you create a cloned cluster, magic happens. The HSM that you create in the clone cluster is cryptographically identical to all the other HSMs in the original cluster, which means they share the same masking key, and you can swap keys between these cloned clusters without ever leaving the FIPS boundary. Right? Now, the difference is the service only recognizes an individual cluster. So we will synchronize the keys within a cluster across the HSMs for you. But we have provided tools for you to manually synchronize across clone clusters. So if you need the same keys available across different regions, if you need to shard your clusters because you're running out of key capacity, for any of those reasons, you have a safe inside the FIPS boundary method of synchronizing even non-exportable keys. All right, so there are two ways to use Cloud HSM. You can use it in direct transaction mode, which means you're calling to your HSM every time you make a call. So for example, if you're running a web server and the web server keys are on your HSM, every time someone says hi, you're reaching to the HSM to set up a session, right? The other way that you use it is envelope encryption. This is typically used for databases, for example, where you have one master key that's on the HSM. You reach out to it for bootstrapping. Then you decrypt all the client keys, use them locally, and then you're off to the races. So for direct transactions, you want to pay a lot of attention to your availability, to your latency, and to your performance. And we'll talk about some practices to get your performance up to as high as it can be. With envelope encryption, you're really just worried about durability, and we take care of that for you. So it's a lot simpler to deploy those types of workloads. All right. So now that we're ready to get working with our HSMs, this is the cast of characters that you get to deal with. The service API is really the only thing that is familiar AWS territory. Right, so this is your create cluster, create HSM, delete backup, copy backup. You can control access to these calls by role-based access control. You can see them in CloudTrail. Once you've created the HSM and you want to transact with it, you're leaving what we call the management plane or the control plane, and you're going into the data plane. That data plane is end-to-end encrypted between your client and your firmware, and we can't see any of it. So we have the Cloud HSM Management utility. It's a command line utility that you use for routine management, create user, delete user, set quorum policy, stuff like that. You have Key Management utility, which is sort of a utility of convenience for those who have infrequent crypto operations or those who don't want to write custom applications. It is scriptable in single command mode. I'll show you how to use that. We also have SDKs. So industry standard PKCS11, industry standard JCE, and OpenSSL. We also have Windows CNG and KSP for things like IIS integration. And then underlying any of the SDK-based apps or the key management util is the client daemon. And this is what implements the high availability, the failover, the load balancing, all the magic that makes Cloud HSM transparent to you. I want to spend a minute talking about the Cloud HSM Management utility. This one doesn't use the client daemon. So specifically, when you create a user or you change the password, the service does not automatically synchronize this across HSMs. It's dangerous for us to do that because your HSM can get locked out if anything gets out of sync. Right? So when you use Cloud HSM Management util, you want to make sure that the configuration file that starts it up has the latest snapshot of all the active HSMs in your cluster. And you can do that using the configure-m utility. This is provided as part of your installation. You just have to make sure you run it before you start up the management utility. And don't add or remove HSMs while you're making changes to your users. Right? Generally, you will run this utility in what we call global mode. So you start it up, it connects to every HSM in your cluster. Whatever command you give it, it will run sequentially on every HSM in your cluster. And it will give you a trace that tells you whether that operation succeeded or failed. You can run Cloud HSM util in what we call server mode, where you're talking only to one specific HSM and not all of them in sequence. Sometimes you actually do get a cluster that's out of sync. You changed a password, something didn't work, you forgot to update the config utility, something got out of sync for some reason. That's when you can go into server mode. There are also power user ways of doing key synchronization across cloned clusters that you will do in server mode with Cloud HSM Management util. But generally speaking, if you're just getting started with the service, stay in global mode. It will keep you out of trouble. All right, so we'll deep dive. The first section of the deep dive is designing for resilience in cross-region mode. Generally speaking, you know that AWS loves the notion of regions. We don't generally want to have an application in one region reaching out to resources in another region. It messes up the availability story. We're not huge fans of it. But what you can do is replicate your keys to cloned clusters that are present in multiple regions. And that gives you the benefits of cross-region DR without losing any of the benefits of regional isolation.
Or indeed, you could be serving different users in different parts of the world and using applications deployed in different AWS regions around the world to give the best user experience as well, for example.
Absolutely, absolutely. And so what we see a lot of customers doing, for example, is you'll create intermediate CAs that are identical in every region and then issue worker certs that are unique to that specific region. Or you'll have master encryption keys that are identical worldwide, and then you'll have data keys that are unique to that particular region. So different use cases for this. The first step is to create the cluster the way you want it, including a Bootstrap Wrapping Key. And we'll walk through this step by step in the next slide, but I want to give you an overview of the process here. Once you have all the users and the policies and the Bootstrap keys that you want, you'll take a backup, you'll copy it to a new region, and you'll create a clone cluster. Right? So now you have cryptographically identical HSMs in both destinations. Now you have two options to synchronize keys on the fly. You can either extract an object that's encrypted with that masking key we talked about, which is unique to the cluster and never leaves it, or you can actually wrap and unwrap using a Bootstrap Wrapping Key. But either way, you've got a trusted, safe, cluster-specific way of getting keys across from one cluster to another. So if you were to do this using wrapping, right, what you'll see is in the original cluster, we've created Bootstrap Wrapping Key. This can be an asymmetric key or a symmetric key. Generally speaking, customers tend to prefer symmetric keys because it's a more lightweight operation. It's easier to track. It's more standard. But it can be anything you want. And so when you clone it and move it to the other side, you notice your Bootstrap key is already in the destination cluster. So when you have a new key that you want to move over, you use key management util. You call the AES wrap for the new key with the Bootstrap key, get it out, it's a wrapped object. You can copy it across as 3 buckets, you can really move it over any way you want, email it to yourself, and then you unwrap it on the other side. Because you have the Bootstrap Wrapping Key there, you can unwrap the key and you're off to the races. If you want to do this using masked objects, it's a little bit different from what you may have normally seen. So in this case, you're going to rely on the masking key that's already built into your HSM. There's no other bootstrapping key that you require. However, you can only do this across clusters that are cloned. There is no other way to share a masking key. So you use key management util, you use a command called extract masked object. It will wrap your key with that masking key, give it out to you. Again, you can copy this across as 3 buckets, email it to yourself, do whatever you like. Once it's on the other side, as long as you're in a cloned cluster, you will have your key back. And there you go. So quick demo of how you would do this. There are a couple of things I want to point out here. So we're running key management util in single command mode here. Right? This is how you script the command line utilities. If you don't want to get interactive and do Python pexpect scripting, you can just run this sequentially in single command mode. I'm finding the keys here. You can see I've got 3 keys present. Those are the handles. I'm going to extract masked object on the one with handle 262151 in this case, and I get the masked object out. So then what we're going to do is, for simplicity, I'm just going to import it back into the same cluster. Typically, you will move this to a different place, run key management util on whatever destination cluster you have. But again, at this point, we're inserting masked object, just that same file. And now if you do find key, you can see I've got a 4th key with that new handle. Most importantly, this key has the same attributes as the original key. If I shared it with different users, it has the same sharing properties as the original key. And if I had things like trusted attribute, unwrap with template attribute, C_derive, any of the permissions or quorums that you had associated with that key are going to transfer over as is to the system. Right? So quick comparison, masking versus wrapping. We get this question a lot, which one's right for you? Masking is proprietary to Cloud HSM, so you're not going to have it through PKCS 11 or JCE. Generally, you want to use masking for the bootstrap keys, the ones that are going to enable you to do programmatic wraps and unwraps in bulk crypto. Once you have your bootstrap key across with masking, you can use wrapping and unwrapping to do whatever you want in bulk. If you have any questions about this, we'll be here by the side of the stage at the end. We're happy to answer any questions at all that you have. We'll also share our email addresses at the end, and you can email us. All right, so optimizing performance and cost. Quick show of hands. How many folks here think that their HSMs are too slow? If you're using HSMs already? They're slow, right? Yeah. How many folks are worried about the network latency and the throughput of their applications? Pretty much everyone. All right. So there's something you need to understand about network HSMs, right? They are making network calls. And this is fundamentally different from on-premises applications where very often you have servers that have the HSMs wired directly into them. Any transaction that you make is going to have a minimum round-trip latency to the HSM, then whatever time of execution you have on the HSM, plus if, let's say, you're creating a key or you're deleting a token key, the additional time it takes to safely synchronize that to a minimum number of nodes in the cluster. Right? Now, there's ways around that. So the first thing is you want to maximize your utilization of your HSM, which means you can't single thread all your crypto calls one behind the other. right? What that's going to do is you will have a network round trip, you'll do some crypto, you'll come back. 90% of the time your HSM is sitting idle because the HSMs are fast. It's the network that's causing the delay. So you want to multi-thread your application. We recommend at least 150 to 200 concurrent threads if you're doing bulk crypto like AES, right? We recommend at least 50 threads if you're doing something more heavyweight like sign or verify. But that's when you're really going to start to load your HSM. And you'll realize that you're past the point of loading it anymore when increasing the number of threads doesn't give you an increase in throughput. So again, the individual call latency isn't going to change, but the throughput will start to go up as you parallelize these transactions. Now, the second part of this, of course, is the operation itself. There are a number of ways to initiate a crypto algorithm in PKCS11 or in JCE. Very often, you're used to finding a key by a label or an ID first, getting the handle, and then using the handle to do the crypto operation. The problem with that is you're making multiple calls to the HSM, and so you're incurring that network latency multiple times. If you're going to be using the same key over and over again, we strongly recommend you find the key once, cache the key handle once, and then use the handle to do all your operations. Generally speaking, that's going to give you a 10 to 20x speed up in throughput, just by caching the handle. The other thing I want to cover, and this is more specific to Cloud HSM, you generally have not seen this with other forms of HSM. We have two types of keys. We have persistent keys, which you are creating on the HSM as long-lived keys, and you actually want to have exist on every HSM in the cluster for the full duration of the cluster. These take time to create because first you generate the key, then you make sure it's replicated across a minimum number of nodes in your cluster, and then the call will return as successful. On the other hand, you can very often get away with session keys, right? So session keys are keys that you're only going to be using in that particular context. If you're using SSL offload, for example, your session key is always a session key. Once the session goes away, you don't need it. And you don't need to have multiple HSMs replicating that key. Very often, you'll have applications with millions of keys, right? Millions of data keys or hundreds of thousands of key pairs for your users. Each HSM can only store 3,500 keys, so you're not going to keep these in memory for the entire duration of your application. What you're going to do is you'll create a key pair, for example, when you enroll a user into PKI, and then you'll wrap that key out with a persistent key that stays in your cluster, store it in a database, DynamoDB, or whichever one you want. Then when that particular user needs to authenticate, you'll pull that key in, which means you'll unwrap it. You'll do whatever you need to do in terms of sign or verify, and then you're done with it. Those operations can be done as session keys. That means, A, you're not synchronizing across every single HSM. B, you're not writing audit logs for a key management operation on every HSM. C, you're saving storage space. You're maximizing capacity. And D, you will get on the order of 25 to 50x faster throughput. Right? So wherever you can use session keys, use session keys. You will have better utilization of your HSMs. You will have faster throughput. The only thing you have to be careful is you have to manage your retries well. For whatever reason, if your connection to your HSM snaps in the middle of an operation, the session keys are cleaned up. And so if the operation fails, you have to watch for it, and then you have to go back and retry.
Here's it's a really good segue again when you look at the AWS Cryptography SDK, which does things like key caching for you on the client side. It can make things really fast. But again, way at the back end sits KMS there and another HSM. So you're getting many of the benefits here of this exceedingly complex HSM world with the simplicity of an AWS service and API when you look at things like our own crypto SDKs.
Yeah, no, I think that's entirely fair. The other thing that I should call out here is there's no inherent throttling in Cloud HSM, right? Because we can't see what calls you're making to your HSM. So as you're looking at your latency and your throughput, as you're doing your load testing, you will have to make sure that you throttle incoming calls to the capacity that you can get off of your cluster. And what capacity you can get depends on the types of operations you're doing, right? Someone did a really good job.
Becky always does a wonderful job.
She does. That actually explains it. That explains a lot. So if you, I lost my train of thought. If you're going to be using, what was I talking about? Throttling, thank you.
Performance monitoring.
I'm so much in awe of her. It's like, if you can hear Becky talk, you really should.
Can we at least have a bigger clap after this session? Anyway.
Thank you. So when it comes to throttling, your HSMs will do the best they can, and then they will simply block until the previous calls have been processed. As you start to see drops in throughput or you see increases in latency, you have the choice either to start to throttle incoming calls to your application or to add HSMs to your cluster, right? And so at some point, you're going to run out of all the optimizations that you can do here. At that point, you're going to have to add HSMs to your cluster in order to get the additional throughput that you need. How many HSMs you need in a cluster depend on a couple of things. What types of operations you're doing, right? If you're generating RSA keys in bulk, you're going to need many more HSMs. If you're doing bulk AES, it works at wire speed, and probably 3 will be enough. For any production cluster, you need at least 2 HSMs spread across AZs. We call this a multi-AZ cluster. Our SLA does not apply to single HSM clusters.
And there's an interesting thing here, we don't have any insight into what the HSM is doing because it's yours and you have an encrypted connection. So you can't get this automatically in CloudWatch, for example, where normally we would say look at metrics of things and make a response. But at your application level, you could be sending your own metrics up to CloudWatch so that you can then hook into the rest of the AWS automation world to say, my HSM's obviously slowing down, create more in my cluster using the AWS APIs. So you can still create this kind of hybrid approach where you've got full control and full insight into this HSM, but use some of the other AWS features to get better at the automation side of it.
Now, there's one other thing I want to call out. Our HSMs publish health metrics to CloudWatch. If you see an HSM unhealthy, or if you see metrics doing strange things, generally you don't have to respond to it. We watch those metrics for you, and we will replace the HSM for you. The one exception is when the HSM stops emitting metrics. Because at that point, our service doesn't know whether it's the metrics system that's broken or the HSM that's broken. And we will wait until we get explicit unhealthy metrics before we replace the HSM for you. Your application, on the other hand, knows if the HSM's there or the HSM's gone. So that's the one situation where you may want to proactively add an HSM to your cluster. For anything else, you can note the unhealthy metrics, but know that we've got it covered. Cost management. This is hands down my favorite slide. I'll give everyone a minute to take a picture, and then I'm going to walk across the stage for you.
All of this is going on YouTube as well. So after these sessions, you can come back and review this. For the Scottish speaker, you may want to slow the speed on YouTube, for example.
So with traditional HSMs, we're generally used to provisioning N+1 for peak load and keeping those HSMs alive forever, right? You don't have to do that for the new Cloud HSM. For one, it's elastic. For two, there are no provisioning fees. And for three, it's zero config, high availability. You can add and delete them as you go. So you can cut your development costs by 60 to 75% just by deleting HSMs when you're done for the day or when you're not actively testing against the HSMs, right? When you delete the HSM, we take a backup. When you recreate an HSM, it spins right up where you left off. We have an IP address flag in the create HSM call where you can specify the exact same IP address that you had before, and so you don't even have to rebootstrap any of your config files. We've generally seen vendors who are building entire services based on Cloud HSM spend less than $400 throughout their dev, test, and POC. You should not have a high bill for HSMs when you're in the dev test phase. When you're in production workloads also, you can leverage elasticity, right? Not everyone has the same peak load 24/7. If you're signing certificates, you may only have to sign at the end of the month or at the end of the quarter. If you're doing something like BYOK, you may really only need your HSMs once a year. Create them when you need them, delete them when you're done. You can get a lot of money saved that way. You
could use CloudWatch to automate this again on a schedule, so that as you come into work in the morning, your HSM fleet's up there ready for you to develop, and it automatically turns off at night, for example, as well. So again, even though this is a very specific service, you still get the rest of the AWS world available to you to do all the regular automation around.
Absolutely. The other thing to optimize cost, again, remember you don't have to run backup HSMs in other regions just for data durability. You can copy your backups over. It's a zero-cost API call. It can be automated. It can be worked into your application. You don't have to spend money on it. You can maximize utilization by sharing clusters across accounts, right? The HSM lives in your VPC, but you can do VPC peering across accounts. And so if you have HSMs that are only used once in a while, create a centralized account, manage it through a centralized security office, delegate access to whoever else needs to.
Use transit VPC, use any other mechanism to make that available anywhere. It's just an IP address on an ENI at the end of the day.
And then to optimize storage, again, if you're not going to be actively using a key, just wrap it out. It takes a few milliseconds typically. If it's an asymmetric key, a little longer to unwrap it back in. Use it on the fly. You'll save a lot of capacity. When you have idle workloads, you can not only delete all the HSMs, you can go forth and just delete the cluster. Even though the cluster doesn't really cost you anything, it does take resources in your account. And so the backup is still there. You can create a new cluster from the backup, again, pick up where you left off. So with that, I'll quickly go through the recent launches. In the last year, we've shipped a Windows client. So you can now do IIS server offload on Windows. You can sign anything you want with Sign Tool. You can use Active Directory to run a PKI using keys housed in Cloud HSM. We have JCE samples on GitHub. I know this has been a pain point for many customers. We're still not happy with the volume of Java samples we have. We're continuing to add to them over time. We're welcoming contributions from our users. But you can find all the basic usage, all the performance optimization, and most importantly, login manager samples for handling network disconnects on the GitHub now. As of last year, we're fully compliant with the PKCS spec. The latest client version is 2.0. We strongly recommend you download that if you haven't already. Check on our software version history page periodically so that you can get those updates. And then we have backup management. So an important thing to cover is when you rotate user credentials, make sure you delete all the old backups as well, because otherwise someone could use an old out-of-date credential by using an older backup to clone a cluster. So you can delete backups, you can copy backups as we looked at, and you have your audit logs in CloudWatch. So with that, I'm going to turn it back to Squig to talk about the feature we're most excited about, which is custom key store.
Thank you, everyone. So last year, we also introduced AWS KMS Custom Key Store, and one of the things we talked about earlier was were customers certain that KMS was actually an HSM-backed service, for example. What we've given you is the full use of KMS, which means you got all the AWS service integration. You get the use of the AWS Encryption SDK, for example, but then this choice of your own HSM fleet. So KMS has its own fleet of hardware security modules. Always. But they're level 2 validated, and some customers in some markets in financial services, for example, sometimes have a level 3 validation target they need to meet. So Custom Key Store now allows you to meet a level 3 validation target. You've still got all the really nice key management features that KMS gives you, but all of the cryptographic operations are performed in your Cloud HSM cluster. So again, really wide variety of choices here at your disposal that hide the terror of what Avni's shown of running an HSM fleet with the simplicity of KMS sitting in front of it. This shows you the comparison across all of it. I'm not going to go down to this in detail, but again, KMS has concepts like key policies that make it really easy to put good cross-account access control around keys, for example, so that you can specify who can use these keys and what can they use them for in a way that would be very, very difficult if you're using the raw HSM. Charges are similar. The difference is with Cloud HSM, you have to have these HSMs up and running continuously because KMS may be calling them at any point in time. So these are not Cloud HSMs that you're going to be able to turn off overnight because KMS wouldn't work anymore. As you know, an EBS volume needed a new data key because you've integrated KMS with the EBS service, for example. So that's it from us. Now you know the right tool for the job. Hopefully the first half of this showed you the services available, and hopefully the second half terrified you to go back and look at the first half again. and think, I don't need an HSM. I can use one of these managed services to achieve exactly the same goals without the complexity of running your own HSM fleet. But then finally, when you do need your own HSM fleet, and we do have customers that need it, hopefully this gave you some more insight into that. So thank you, everyone.
And again, if you have any questions, we'll be hanging out by the side of the stage here.
And take some questions.
Thank you all for coming.
Here's our email addresses. You can get in touch.